All right, moving to the practice problems associated with sample problem 4-2. Start with the very first one. 1A. Write both the complete electron configuration notation and the noble gas notation for iodine, represented by a capital I. How many inner shell electrons does an iodine atom contain? So, one of the first things we want to do is we want to find iodine on the periodic table. And after some searching, you might find that it's number 53. And if you don't find that it's number 53, good luck to you, because it's not going to work out very well. But we see that it is in period 1, 2, 3, 4, 5, and group 17, or the seventh main group, however you'd like to look at it. So we're being asked for two different configurations here. First is the complete electron configuration. So let's do it. So first off, again, following the how should I say? I don't want to say. So one of the things you want to do when you're starting off with your configurations is simply follow along on the periodic table. That's the best hint that I can give you. Trying to do things like this just off the top of your head don't typically work out, especially when you're starting out. So here is my iodine. It means that I have to go through all of these 52 prior elements before I get to iodine. And I have to represent every single one of these electrons. I have to represent 53 electrons. So let's get started. So again, following along in your periodic table, you find that what you first come up to is the 1s. Okay, and we're going to put 2 electrons in there. And then again, following the off bow, we come to the 2s. We're going to put 2 in there. Then we come to 2p. Sublevel can hold 6 electrons. And then we're on to 3s. Again, s sublevels can hold 2 electrons. Now 3p. P sublevels, again, can hold 6 electrons. Now, here's one of the kind of annoying things about writing these electron configurations is that I just finished writing my 3p6, right? So that gets me up to 18 electrons. And in terms of the order in which these electrons filling the 4s sublevel is next. Okay, absolutely, we're going to fill the 4s sublevel with 2 electrons, right? Which would be electrons numbers 19 and 20. We're going to fill those electrons, that sublevel before I fill the 3d sublevel. It's absolutely true, 100% accurate. However, kind of annoying thing is that when you go to actually write your electron configuration, you consolidate all sublevels in the same main energy level together. So that means that even though the very next electrons that I'm going to fill go into the 4s, I'm going to write my 3d electrons first, simply because all the 3s get grouped together. Not because that's the order in which they fill. Like I said, the 4s electrons would actually fill first, but I grouped there's only one. I grouped the 1s with the 1s, I grouped the 2s with the 2s, I grouped the 3s with the 3s, and I grouped the 4s with the 4s. Okay, and I know that's going to be pretty frustrating for a lot of you, and I hope we can minimize the number of students who kind of fall prey to that problem on the test. But again, we've gotten through 3D sublevel, so that we've already represented our 4s electrons. Now we're on to the 4p. Again, p sublevels hold 6 electrons. Again, after 4p, I'm going to fill the 5s, right? It'd be 5s2, but in order to get to iodine, I have to go all the way to 4. Okay, this is 4d, starting at deuterium and cadmium. I have to represent all of these electrons. All right, that's going to be 4d10. I actually have to write 4d10 before I write 5s2, Not that's the order in which the electrons fill, but when I write these electron configurations, I have to group all of the like energy levels together. So now I can go 5s2, 5p. Now, how many electrons in the 5p? Right, so it's 1, 2, 3, 4, 5. Okay, 5p, 5p, 1, 2, 3, 4, 5. So it's going to be 5p5. And that's going to be your complete electron configuration notation. The other thing that I'm being asked for is the noble gas notation. And so what that's going to do is going to present all the inner shell electrons with of the preceding energy levels with the nearest noble gas. And so I'm still talking about iodine. Iodine, what's the nearest, but backwards, right? Gotta go back to the nearest noble gas. So yeah, let me see if I can get the whole thing in the whole period in view. Okay. So iodine, go backwards. I find krypton. Okay, so krypton's number 36. So I'm going to write krypton, Kr, put that in brackets. Now that I represented the first 36 electrons, again, how I know it's 36, I've represented the first 36 electrons just by drawing Kr, krypton. Now I'm off the hook for drawing those first 36. All I have to do is represent electrons that fill after that. Okay, so I'm going to have to represent the 5s2, the 4d10, and 5p5. Okay, I'm going to represent all of these here. Now remember, yes, 5s electrons are going to fill first, right? That 5s sublevel is going to be filled first, and then the 4d. But remember, because the fourth main energy level comes before the fifth, I actually have to write my 4d10 first. Then my 5s2, 5p, oh, 5. Oh, messed that up. So 5p5. Okay, and so I don't actually have to write this, okay, in those 36 electrons. You can actually add those exponents up. I'll prove it to you that it's 36. I don't have to write all. I only have to read that. I can represent this entire list of electrons just by writing Kr, and it saves me a whole lot of time. Okay. Now, last part of this question: how many inner shell electrons does an iodine atom contain? Okay. So inner shell. What's the highest occupied energy level here? You see that N is equal to 5. So the question is, excluding electrons that are in the fifth main energy level. So that's energy levels 1, 2, 3, and 4. If I add up all of the electrons in those 4 main energy levels, how many electrons will I get? Now I'm pretty far along in the periodic table, so actually I'll go backwards. I'll just say how many electrons are in the is equal to 5 energy level. Well, iodine, this is 5s. I have 5p5. So 5s2, 5p5. So that's 7 electrons, right? 2 from the 5s, 5 from the 5p, right? So 2 plus 5 equals 7. So 7 of these electrons are in the highest occupied energy level. Well, hopefully you remember, iodine is number 53. Okay, so I have 53 total electrons minus 7. Let's just go, I won't go outer shell electrons equals 46 electrons. Well, if they're not in the outer shell, what are they in? What the question is asking for, turns out, inner shell electrons. Okay. One issue here is you might think that Kr is representing all of the inner electrons. Not exactly. It's representing most of them, but don't forget that these 10 4d electrons are in fact in the fourth main energy level and technically are inner shell electrons because that outer shell is N is equal to 5. So we only subtract from the total number of electrons the electrons that are in the actual outer shell. All right, let's move on to B. How many electron-containing orbitals are in an atom of iodine? Okay, so how many orbitals? How many? how many of these orbitals are filled? And so, again, we need to make sure that we're aware, or we're talking about singly filled or doubly filled, whatever. How many unpaired electrons are there in an atom of iodine? Okay, so let's get to it. So, if I steal my notation that I wrote up here, okay, so 1s, okay, so I have S, 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 S. You guys see that? So I have 5, count them, 5 different S sublevels. So I have 5 S levels. For P, I have 1, 2, 3, 4. I have 4P sublevels. For D, I have 1, 2. All right, 2. Okay. Oop, not even writing on camera. Okay. So I can just look at my configuration and I see that I have 5 S sublevels, I have 4 P sublevels, and I have 2 D sublevels. Well, every S sublevel has 1 orbital. Every P sublevel has 3 orbitals. Every D sublevel has 5 orbitals. So 5 times 1, 5. 4 times 3, 12. 2 times 5, 10. So when I add all of these orbitals together, I get, 27. 27 orbitals in iodine. I'll draw it like I don't usually write my I's that way, but I'll do that so it's a little bit easier to understand. So there are 27 total orbitals in iodine. Next question. How many orbitals are filled? Okay, now, here we're actually meaning are completely filled, like doubly filled, like 2 electrons. How many orbitals have 2 electrons? And that's important to remember. Now, if you're in a position where you're taking a test, especially me, and you're not exactly sure, are you talking about filled all or doubly filled, well, you just ask, and I can clarify that. Or you can read the next question, right? How many unpaired electrons are there in an atom of iodine? So that's indicating a different question, okay? And so that's kind of evidence that we're talking about doubly filled here. So what we can do is we can go back up to this electron configuration, and with all these orbitals, we actually see that all these orbitals are doubly filled, completely filled, with the exception of this 5p5. Okay, this 5p5 right here is missing 1 electron. So this last 5p orbital is only singly filled. Now every other orbital is doubly filled, but not this last 5p orbital. So what that means is there's 1 orbital that's not doubly filled. Okay, so 26 orbitals are filled. Okay, so part of the question, how many unpaired electrons are there in an atom of iodine? Again, this 5p orbital here, I'll draw it. I'll draw orbital notation just so we can see. So 5p, again, p sublevels have 3 orbitals. So we go up, 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 right? So we can set a Hund's rule, and then we'll go down, down, right? 5p5, 1, 2, 3, 4, 5. We see that there is 1 electron that isn't paired, and so we have 1 unpaired electron.